Why are tornadoes more destructive every day? Let's talk about one of the most devastating forces of nature. That it seems, just like the others, to gain more and more power. Hello. My name is Paul and we'll talk about tornadoes. As always, I'm very glad to talk to you once again. So let's talk about these catastrophic events. Especially since we just had this December 10th of 2021 a series of tornadoes as we have never seen before. So let's begin by pointing out that tornadoes cause lots of fatalities every year, along with tremendous losses in goods, infrastructure, harvests, and so on. Nevertheless, and according to the records that we have of these events, we begin to notice that year after year these phenomena gain more and more power. Here for example we have a clue of what is being going on in the southwest of the United States. Let's say around the Mississippi Basin, where without any historical record whatsoever, more than 20, easily about 30 tornadoes, impacted 7 states in one single night. This is the area that we can see highlighted on the map, between Ohio, Kentucky, Mississippi, and Arkansas. All this area got decimated by a series of powerful consecutive tornadoes, of which there isn't a historical precedent in more than 100 years. Or pretty much since a record was created. So we have never seen this type of devastation before. And according to the National Weather Service, 37 tornadoes were reported in different states. An immense area that goes from the Great Lakes, all the way to the Gulf of Mexico. All this area was covered by 37 tornadoes. And although there's already plenty of information out there, one particular image that stood out to me was this one. More than anything because we are talking about a train that should have weighed around 30 to 40 tons. So if these tornadoes had the force to move something like this, they could have easily moved a car or a truck. Just imagine a force capable of moving something in the order of dozens of tons. And let's calculate what could this same force have done over the structure of a building or a house. Let's for example take a closer look at one of these tornadoes. An F3 category. Remember that tornadoes go from F1 to F5 category. So this F3 category descended with winds of 60 miles per hour or about 250 kilometers per hour. Pretty much the same force as the biggest hurricanes on record, but focused on this small vortex that forms the tornado. And with this same force, it traveled through roughly 100 kilometers. So just imagine the cone of the tornado descending upon the earth and moving across the ground with tremendous force, with nothing to stop it in its tracks. Creating a cone on the ground of 400 meters in diameter. So everything that it touched, it will disintegrate, like the finger of God. Including trains such as this one. An overwhelming power for sure, but that if we check the records, seems to be increasing year after year. So whether or not you believe in global warming or climate change, something is going on. As we can read here, Friday's storm may go down in history as the most destructive tornado. Easily surpassing the record of the 3-state tornado that swept through Missouri, southern Illinois, and southwestern Indiana in March 1925. Of course, you can go and look it up by yourselves, as I rather not showing images of this tragedy. Since more than anything, our intention in this channel is trying to first, find an explanation for this phenomenon, and second, a way of preventing them from a structural design point of view. Let's then get to it, and take a closer look at this diagram. So above ground, and as the sun heats the environment, evaporation occurs, creating warm air that flows toward higher altitudes. And as we know, the higher the altitude the colder the air gets. And vice versa, as we get closer to the sea level, temperatures get warmer. You get the idea. So commonly, in the area of the Gulf of Mexico there is a great deal of insolation and evaporation, and hence of warm air. When this current of warm air, coming from the Gulf of Mexico, collides with the cold winds coming from the North Pole, they battle each other, so to speak, and create this swirl effect, which in turn may produce a tornado. So going back to the previous image, we can see that the warm air coming from the ground collides with currents of cold air, creating a swirl effect as the cold winds, due to their weight, battle for going down, and the warm currents for going up. We can see another example of this happening in places like Mexico City, creating an effect known as thermal inversion, in which the cold air from the previous night gets trapped underneath the warm winds of the sunrise. And well, sadly, it's also between these two layers of air that smog and pollution get trapped. Now, this also happens because above both these two layers, we may have a third layer belonging to a polar air mass. So you get the point. When these two currents collide with each other, they fight for moving in the opposite direction. This commonly happens in a seamless way, creating storms and rain that are very useful for our agriculture. However, what may happen instead is that both currents collide with great strength, swirling violently in opposite directions, and the cold ones envelopes warm ones. In this image, we can understand the warm air represented by the yellow arrows, and the rest in blue, as cold air. So the warm air gets trapped inside the cold one, as both begin to swirl. Of course, when we have really big masses of air, these form hurricanes. But when these are smaller, and collide with each other in relatively narrow areas, and at high speeds, these types of vortices are created. And as it swirls at these high speeds, this further attracts warm air into the vortex, which simultaneously tries to move to higher altitudes, displacing the cold air in the opposite direction. And this cycle continues, not just increasing the power of the tornado but creating a vacuum effect. Actually, isn't the pressure caused by the tornado or wind the one that causes most of the devastation, but the ensuing suction effect? So, in going back to what we mentioned earlier, from a structural design point of view, we should understand that when designing the roof of a building, such as that of a warehouse, what we should worry about isn't that the roof can support the wind pressure, but its suction effect trying to rip it apart from the rest of the building. As a matter of fact, this isn't a problem so out of the ordinary. But of course, there are already several types of analyses that can be carried out over our structure regarding this issue. Although in this particular case we are talking about speeds above 200 meters per second, and thus a really powerful suction effect, capable of taking entire vehicles and even houses. Of course, when it comes to a structure, the tornado can't take the entire thing in one go, but it does shred it to pieces and take it away. But moving on, in this image, we can observe several stages of the formation of a tornado, in which, and as I explained earlier, rising hot air gets enveloped by the cold air current. And when the cold air touches the ground, it further drags hot air into the vortex, creating a powerful suction effect, being this the main force behind the massive destruction left behind. So once again, all this begins with the clash of two air currents of opposite temperature, which instead of just creating rain, produces an incredibly destructive force. In this next picture, we can see a more clear example of this, and how is that these two currents are colliding. Really good picture in this regard. Moreover, we can also observe the presence of some rain. Nevertheless, and if there isn't enough humidity in the air current, such as the one coming from the Gulf of Mexico, the formation of these tornadoes, at least at some degree, is very likely. Here we have yet another image in which we can more clearly observe the suction effect caused by the tornado. And as long as these two currents keep colliding, one coming from the Gulf of Mexico and another from the North Pole, these tornadoes will keep feeding themselves, growing in speed and power. This isn't different from draining your bathtub. The speed and force of the swirl are directly related to the mass of water being displaced. So in the case of these tornadoes, their speed and power are directly related to the big masses of air coming from both sides, the Gulf of Mexico and the North Pole. It's then the displacement of these masses that creates these swirls and this type of lenticular clouds. Here we have a short clip of the devastation caused by an F3 tornado that traveled 100 kilometers during the evening. Just imagine how terrifying it must have been to witness this, it not just the size of the thing, but the thunderous sound that it produces as it destroys everything on its path. Not short from an actual monster. Now if this is somehow related to climate change of some kind, well, I wouldn't doubt it. But what we can do about it? Well, the issue is quite complex. And I'm not the one to discuss it. Our job in this channel is to discuss solutions from a structural design point of view, if at all possible. Let's now take a quick look at the different tornado classifications. First, we have the waterspout, the most common type and relatively short in duration. Next up we have the landspout. The diameter of this tornado can be particularly ample, and thus it can be very destructive. Finally, we have the multiple vortex ones, which are the most terrible. Now, something to mention regarding this last type of tornadoes is that up until the last few years, these weren't a common occurrence. I remember back in the day when this type of tornadoes was only seen in science fiction movies. But now look at this next picture. This isn't even Texas or Arizona. This is a state in Mexico. We are seeing 4 vortices together. So this happening all over the place. Not just in the United States. And if you want to know more about the most devastating tornadoes, just take a look at what happened in Sataria, Bangladesh, on the 26th of April of 1989. So how do we actually protect against tornadoes? Well, to begin with, and talking about science fiction movies, in one of these movies people seek protection under a bridge. However, this is actually a very bad idea, since the tornado will create a Venturi effect throughout the tunnel, as the wind will increase in speed while being forced through a narrow space. So doing such a thing would be actually quite dangerous. Perhaps the best thing to do would be to just get away as fast as possible from the place. Luckily, the formation of tornadoes can be detected through the use of radars, and alarms can be promptly issued. Let's now take a quick look at the Fujita scale of tornado intensity. We find from the F0 scale, all the way to the F5 class, which produces an immense amount of damage. And it's even capable of lifting entire cars, launching them through the air. Now in this particular event, and according to the information that we have, we were dealing with an F3 class tornado. Although the destruction that it caused was still massive. Of course, we don't intend in this channel to overly focus on these images, but instead to propose some kind of solution from the structural design point of view. So having said that, what can we do to prevent, or at the very least mitigate this type of destruction? Again, we can't know for sure what caused this particular event to happen, but whatever the reason, climate is changing, and hence we need to adapt. This means that we need to calculate our structural models so they can endure these new conditions. Although the easiest way to take action is to check that our model complies with the regional code regarding wind loads. Since there are many places outside the United States in which wind conditions can be detrimental to the integrity of our structure. Fortunately, nowadays we have several programs that can help us to perform wind load simulations over our model, enabling us to verify its integrity before facing real-life events. So if we already have an idea of the maximum wind load that we may encounter in a particular region, we can use this type of software to help us design our structural model accordingly. Furthermore, we may not even need to redesign the entire model, just some adjustments may suffice to make a huge difference. So it's not just about saving the structure, which of course can be very costly, but it's also about saving lives. Here, for example, we have a tank tower, which may be used for supplying water to a particular region. These types of structures are also very susceptible to wind loads, so it's very important that we design them accordingly. And structural design software can really help us to carry out this process with relative ease. Up next we have a very common type of structure, and that may be used for simple storage purposes. But as I mentioned earlier, it's very important that we also produce a proper design of the roof or steel cover, so this, along with the whole structure, can withstand the force of really powerful winds. And let's remember that wind forces, at least when it comes to this type of structure, are mostly suction or negative forces. So it's not about that the roof can resist the pressure force produced by the wind, but its negative suction effect. Then in this regard, our structure should be properly designed from its very foundations. Of course, this is a very small example, but just imagine the negative forces that are produced in big industrial complexes. We must do everything we can for avoiding this type of damage to happen. And we can only do that through an adequate structural design. Now take a look at more complex structures, such as those of high-rise buildings. This type of structure is usually designed to withstand considerable wind forces, along of course with seismic ones. So due to their inherent design requirements, They aren't usually affected by this type of natural events, or at least not in the same magnitude. Again, the outcome for either type of structure is very closely related to its structural design, and whether it can deal with the ensuing wind loads. Yet again, we can see through this image of this industrial plant, how the suction forces produced by the tornado managed to lift the roof of the structure. And once this came back down, it damaged the rest of the building. Now, and as we have mentioned multiple times through this video, the purpose of this channel is that you feel encouraged to study all these cases from a structural analysis point of view, so you can in turn improve your own structural models, their safety, and the odds of withstanding this type of catastrophic events. So if you are interested in this fascinating discipline pertaining to structural analysis, or if you are just interested in getting more familiar with some of the multiple tools out there that can help you to improve it, please don't hesitate to contact us through our official website. We offer many tools and courses that, just like this video, will explain everything you need to know regarding structural analysis in a clear and simple way. Moreover, and beyond just courses, you will have access to our staff of experts, many of them with a long career in structural engineering, and that can give you a hand in case you need a more specialized kind of support. So please feel free to contact us through this channel, our chat down in our official website, or just drop us an email if you want. And as always, please don't forget to like, comment, and subscribe for more videos like this.